The date is January 17, 2026, and after 5 decades of studying the cosmos through telescopes large and small, I can tell you with absolute certainty that I have never seen anything quite like what I'm about to share with you tonight. In my 47 years as an observational astronomer, I have watched comets streak across our skies, tracked asteroids through their predictable paths, and marveled at the elegant dance of celestial mechanics. But what we are witnessing right now with the object designated 3I Atlas is something that defies every pattern I have learned to recognize in nearly half a century of watching the heavens. You reach a certain age in this profession, and you think you have seen it all. You think the universe has shown you its full repertoire of tricks. But then something comes along that reminds you how little we truly understand, how vast the unknown really is. This object, this visitor from beyond our solar neighborhood, is forcing me to question assumptions I have held for my entire professional life. And I need to share this with you because what unfolds in the coming weeks may very well be the most significant astronomical event any of us will witness in our lifetimes. Let me walk you through what we are seeing, and more importantly, what it means. Just 12 days ago, on January 5th, the Hubble Space Telescope captured new imagery of 3I Atlas that has sent ripples of confusion through the astronomical community. I have colleagues, brilliant minds who have dedicated their lives to understanding cometary physics, who are sitting in their offices at night, staring at these images with expressions I have not seen on their faces before. It is the look of someone whose fundamental understanding of how things work has just been challenged. The images show something that should not exist according to everything we know about how comets behave. There is a jet emanating from this object, but it is not pointing away from the sun as every single comet we have ever observed does. It is pointing directly toward the sun. Think about that for a moment. This is like watching water flow uphill or smoke descend instead of rise. It violates the basic mechanics that govern cometary behavior throughout our solar system. When I first began my career in the late 1970s, one of the fundamental lessons was this: comets are dirty snowballs that respond to solar radiation in predictable ways. As they approach the sun, they heat up, materials sublimate from solid to gas, and this outgassing creates tails that always point away from the sun. Always, it is driven by two forces working in perfect partnership: the pressure of sunlight itself pushing against dust particles, and the solar wind, that constant stream of charged particles flowing outward from our star. Both forces push material away from the sun. This is not theory, this is observed fact, documented in thousands of cometary encounters over centuries of observation. 3I Atlas is producing a jet that extends approximately 400,000 kilometers from its nucleus, pointing straight into the solar wind like a swimmer fighting against a powerful current. To give you perspective, that distance is equal to the space between Earth and our moon. Imagine a stream of material maintaining its coherent structure across that entire distance while pushing against forces that should be tearing it apart and scattering it into a diffuse cloud. The energy required to maintain such a structure is staggering. When we first detected hints of this phenomenon in data from July of last year, there was cautious hope in the community that we might be dealing with an optical illusion, a projection effect created by our viewing angle from Earth. Perhaps we were seeing something that looked sunward but was actually oriented differently. That explanation would have let us sleep easier at night. But the January observations have eliminated that possibility entirely. We are looking at something real, something that is genuinely defying the physics we thought we understood. Advanced image processing techniques, specifically the Larsen-Cecchinina rotational gradient filter, have revealed even more troubling details. This is not a simple jet, it is the primary component of a complex triple jet system, but unlike the other two fainter jets which behave more conventionally, this sunward spike is extraordinarily focused. It is collimated in a way that suggests deliberate engineering rather than natural outgassing. The beam maintains its tight structure, roughly 10 times longer than it is wide, while plunging toward the inner solar system through conditions that should disperse it completely. In my experience, when you see something maintaining this kind of stability and focus in an environment that should destroy it, you are looking at either an unknown physical process or a controlled mechanism. Natural sublimation, the process where ice transitions directly to gas, produces expansion that is either roughly equal in all directions or at least forms a broad cone. What we are observing here is concentrated, focused, almost like watching thrust from a rocket engine rather than steam escaping from a heated surface. The brightness characteristics of this jet present another puzzle that keeps me up at night. At its current distance from the sun, it should not be this luminous. If we were looking at standard dust particles being ejected from a comet, the solar wind would strip away the smaller, brighter particles quickly, leaving behind only heavier, darker grains that would produce a faint, diffuse structure. Instead, this jet remains brilliant and sharply defined. This tells us that either the particles making up this jet are extraordinarily massive and resistant to radiation pressure, or they are being replenished at a rate that is frankly implausible for an object of this size operating through natural processes alone. Here is what truly concerns me. This jet has been active and visible since at least July 2025. We are not looking at a momentary outburst, not a temporary fracture in the surface caused by thermal stress as the object warmed. This is a continuous, stable phenomenon that has persisted for at least 7 months, maintaining its precise orientation toward the sun despite the object's movement through space. Think about what that means. As 3I Atlas travels along its trajectory, as it rotates on its axis, this jet consistently points at our star. In standard cometary physics, a rotating nucleus sprays material in a spiral pattern, much like a garden sprinkler rotating on a lawn. To maintain a straight sunward pointing jet from a rotating body requires the source of that jet to be locked to what we call the subsolar point, the location on the surface where the sun is directly overhead at all times. This implies either that the object is not rotating, which our observations tell us is false, or that its rotation axis has a very specific and highly improbable orientation. Let me take you deeper into the geometry of this situation, because this is where the statistical improbabilities begin to accumulate into something that cannot be easily dismissed. By tracking the subtle wobble and precession of that sunward jet over the past several months, researchers have been able to reconstruct the orientation of 3I Atlas's spin axis. Picture the object as a spinning top. That axis of rotation is not pointing randomly into the void of space. Our measurements indicate that the rotation axis is aligned with the sun to within approximately 7 degrees. In 47 years of observing comets and asteroids, I can tell you that spin axes are distributed randomly throughout space. There is no physical law that requires an interstellar visitor to align its rotational pole with our star. The tidal forces from the sun at these distances are far too weak to have torqued the object into this alignment during its brief passage through our solar system. This means 3I Atlas presumably arrived with this orientation already in place. But the geometric coincidences do not stop there. The object's trajectory through our solar system is also closely aligned with the ecliptic plane, that flat disk where Earth and the other major planets orbit the sun. Most interstellar objects we have observed, such as 1I Oumuamua or 2I Borisov, arrived from random inclinations. They came diving in from above or below the solar system, cutting through the ecliptic plane at steep angles like meteors. 3I Atlas is different. It is sliding in almost perfectly flat, moving within the same traffic lane as the planets, traveling parallel to the plane rather than across it. When you combine these two geometric factors, a rotation axis pointing at the sun and an orbital path that lies flat along the ecliptic, the combined probability becomes vanishingly small. We are looking at better than 1 chance in 10,000. Now, I have lived long enough to know that rare events do occur. Unlikely things happen, but when you see multiple improbable coincidences stacking on top of each other, you have to ask yourself whether you are really looking at coincidence or whether there is an underlying pattern you are missing. In my younger days, I would have defaulted to the natural explanation without question. Random chance happens, even at 1 in 10,000 odds. But with age comes a certain willingness to consider alternatives when the evidence demands it. This specific alignment creates a configuration where one hemisphere of 3I Atlas is in perpetual daylight while the opposite hemisphere remains in permanent darkness, a summer solstice condition that never ends. This maximizes solar heating on one pole continuously. If this were a standard comet, that constant heating could theoretically explain steady outgassing from the lit side, but remember what I told you about the jet. It is stable, narrow, and focused. If the pole is pointing at the sun and the jet originates from that pole, then mechanically speaking, that jet is acting like a thruster firing along the line of the object's motion. The stability of this configuration over months of observation is what troubles me most deeply. natural comets that are non-spherical, and our data suggests 3I Atlas is elongated, typically experience changes in their rotation due to outgassing. We call this the Y-Orp effect, named after the scientists who first described it. The outgassing creates torques that cause the spin to accelerate or the axis to drift over time. Yet 3I Atlas maintains its sunward orientation with remarkable precision. It keeps its focus, if you will, locked onto our star as it travels. This brings me to a question I find myself asking more and more as I examine this data. At what point does a series of statistical improbabilities stop being mere coincidence and start becoming evidence of something else? We have a jet that violates the physics we observe in every other comet. We have a geometric alignment that defies the odds of random chance. These two anomalies are not occurring in isolation, they are occurring in the same object simultaneously. In my decades of experience, when you see patterns like this, the universe is usually trying to tell you something. The precision of this alignment becomes even more significant when we consider where 3I Atlas is heading. It is not simply passing through our solar system on a random trajectory out into the void. As it moves away from the sun, it is on an intercept course with the largest planet in our solar system. The initial conditions we have observed, the spin axis, the orbital path, the jet orientation, they all seem remarkably well tuned to facilitate a specific encounter in the outer solar system. 3I Atlas is heading directly toward Jupiter, and the timing appears to be precisely coordinated. The alignment with the ecliptic plane makes a close encounter with a planet far more probable than if the object had entered our system at a steep angle. And when you run the orbital calculations, what emerges is a rendezvous that is shocking in its precision. On March 17, 2026, exactly 2 months from today, 3I Atlas will pass through Jupiter's gravitational influence at a distance of approximately 53 million kilometers from the planet. This is what we call a Hill sphere encounter, where the object grazes the boundary of Jupiter's gravitational dominance. Now let me explain why this particular encounter is keeping a lot of very smart people awake at night. There is a scenario, highly improbable but theoretically possible within the laws of physics, where 3I Atlas could interact with this gravitational boundary to deploy or deposit material in the Jovian system. If the object were to eject fragments during this passage, or if it were to separate into multiple components, the gravitational dynamics change entirely. A fragment released at precisely the right moment, with exactly the right velocity, could potentially enter into orbit around Jupiter. But here is where the physics presents us with what appears to be an insurmountable problem, and I need to walk you through this carefully because this is where natural explanations begin to break down completely. 3I Atlas is approaching Jupiter at 66 kilometers per second. That is not a typing error, 66,000 meters per second, faster than anything humanity has ever built. At the distance of the encounter, 53 million kilometers out from Jupiter's cloud tops, the escape velocity from Jupiter's gravity is merely 2.2 kilometers per second. This is the speed threshold for capture. If you are moving faster than 2.2 kilometers per second relative to Jupiter at that distance, you cannot be captured into orbit. You fly past and continue into space. Do the mathematics with me. 3I Atlas is moving at 66 kilometers per second. Jupiter's escape velocity at the encounter distance is 2.2 kilometers per second. The object is moving roughly 64 kilometers per second too fast to be captured by gravity alone. For any fragment or component of 3I Atlas to remain in the Jovian system after this encounter, it would need to lose essentially all of that excess velocity. We are talking about a delta V, a change in velocity, of more than 60 kilometers per second. Instantly, at the moment of separation, in my entire career, studying impacts, explosions, and fragmentation events in space, I have never encountered a natural mechanism that could produce this kind of velocity change in a controlled manner. When comets break apart naturally, whether from spin forces, thermal stress, or volatile outbursts, the fragments separate gently. They drift away from each other at speeds of perhaps 5 to 10 meters per second, maybe a few hundred meters per second, in the most violent sublimation events ever recorded. We have never observed natural fragmentation that imparts thousands of meters per second of velocity change, let alone the tens of thousands needed here. To put this in perspective, the kinetic energy required to accelerate a fragment backward at 60 kilometers per second relative to the parent body is comparable to a significant explosive detonation and that energy would need to be focused almost entirely in one direction to produce the required trajectory change. Natural processes do not work this way. Natural explosions expand in all directions. Natural fragmentation is chaotic, not precisely directed. So if we observe a new moon appearing around Jupiter after March 17th, we will be looking at something that cannot be explained by any natural process we currently understand. Natural physics does not provide a braking mechanism sufficient for this scenario. The universe does not perform orbital insertion burns through random chance. A fragment that becomes gravitationally bound to Jupiter would have had to execute a high-energy maneuver, a precisely directed velocity change that cancels out the approach speed and drops it into a stable orbit. Remember that sunward jet I described at the beginning? That anti-tail that should not exist? It demonstrates that this object possesses a mechanism for directed, focused outflow of material. It shows that 3I Atlas can maintain a stable orientation if that same mechanism is capable of producing a high-thrust event, or if the jet we have been observing is actually evidence of controlled propulsion used to fine-tune this approach, then suddenly all these pieces fit together into a coherent picture. There is a concept in the search for extraterrestrial intelligence called a Bracewell probe, named after the physicist Ronald Bracewell, who proposed it in 1960. The idea is that an advanced civilization might send autonomous robotic spacecraft to explore other star systems, much as we have sent Voyager and Pioneer probes beyond our own system. A probe conducting a high-speed flyby of a planetary system might deploy a smaller subprobe, a monitoring station designed to remain behind and observe. To deploy such a subprobe at these velocities would require exactly the kind of high-impulse separation we are discussing. The impossible velocity change needed to leave something in orbit around Jupiter is not a problem for a designed system, it is simply an engineering requirement. If 3I Atlas leaves our solar system intact, but Jupiter gains a new satellite that it did not have before March 17th, the laws of celestial mechanics tell us unambiguously that the new satellite did not arrive there through natural processes. It would have had to be placed there deliberately. I want to be very clear about what I am and am not saying. I am not claiming definitive proof of anything beyond natural origin. What I am telling you is that we have accumulated a series of observations that are individually improbable and collectively extremely difficult to reconcile with a purely natural explanation. The physics-defying jet, the 1 in 10,000 geometric alignment, the precisely targeted Jupiter encounter, the insurmountable capture problem, each of these would be remarkable on its own. Together, they form a pattern that demands serious consideration of alternatives. The term we use in astronomy is technological signature. This does not mean we have a photograph of alien engineering. It means we have observational data that cannot be easily generated by known natural astrophysical processes. The 400,000-kilometer jet pointing upstream against the solar wind, that is a potential signature. The improbable alignment of spin axis and orbital plane, that is a potential signature. The appearance of a captured moon at Jupiter following this encounter would be the most definitive signature we could ask for. March 2026 represents a rare and potentially decisive observational opportunity. We have assets in position. The encounter will be monitored by Earth-based telescopes across multiple wavelengths and critically by NASA's Juno spacecraft currently in orbit around Jupiter. Juno has been studying the king of planets since 2016. The spacecraft is aging, continuously bathed in intense radiation, but its instruments remain functional, and NASA has already adjusted observing schedules to prioritize this event. Juno will not be close enough to 3I Atlas to image surface details. Space is simply too vast for that. But the spacecraft is perfectly positioned to detect the aftermath of this encounter. If 3I Atlas performs any kind of energetic maneuver, if it releases stored energy to slow down a separating component, Juno's plasma wave instrument and magnetometers should detect the disturbance in Jupiter's magnetic environment. If a new moon appears in the Jovian system, Juno's camera can search for it systematically in the weeks and months following the flyby. Usually, these interstellar visitors come and go too quickly for us to prepare comprehensive observations. We discover them late, scramble to collect what data we can, and watch them disappear back into the darkness before we truly understand what we saw. This time is different. This time we have been tracking 3I Atlas for months. We know when and where the critical moment will occur. We are waiting at the finish line with our instruments ready. Let me tell you what the verdict depends on. If nothing unusual happens, if 3I Atlas passes by Jupiter, remains intact, and heads back out into interstellar space without leaving any trace behind, then we will be left with a profound mystery, but one that remains within the bounds of natural phenomena. We will need to rewrite sections of our textbooks on cometary physics. We will need to understand how jets can point sunward and how statistical alignments can occur. It will be an exotic, anomalous comet, perhaps the most unusual natural object ever observed, but still natural. But if something stays behind, if a fragment or component enters into orbit around Jupiter, if we detect a new moon where none existed before, then everything changes. The impossible velocity change I described becomes proof of engineering. The geometric alignments become evidence of intentional trajectory planning. We move from being a species that speculates about life elsewhere in the universe to being a species that has detected evidence of technology created by non-human intelligence. We cross a threshold that cannot be uncrossed. I am 71 years old. I have spent the majority of my life studying the universe through lenses and sensors, translating light into understanding. In all those decades, I never truly believed I would live to see a moment like this. The possibility that we might be observing not just an unusual natural object, but potential evidence of extraterrestrial technology visiting our solar system, it is simultaneously thrilling and sobering. Part of me hopes I am wrong, that we will find a natural explanation that makes all of this make sense. But another part of me, the part that became an astronomer because I wanted to know what else was out there, that part hopes we are about to learn we are not alone. We are exactly 2 months away from March 17th. In my experience, the universe tends to surprise us, often in ways we never anticipated. Whether 3I Atlas turns out to be a freak of nature exhibiting physics we have never seen before, or whether it represents our first genuine encounter with technology from beyond Earth, this object has already earned its place in the history of astronomy. We are living through a moment that people will study and discuss for generations regardless of the outcome. The next 8 weeks will be spent in careful observation, double-checking calculations, and preparing our instruments for that critical passage through Jupiter's gravitational domain. And then we wait. We watch, we document everything with every telescope and sensor we can bring to bear on this encounter. When March arrives, we will have our answer. Until then, I encourage you to watch the sky, to follow this story as it unfolds, because we are all witnesses to something extraordinary. Whether it rewrites our understanding of cometary physics, or rewrites our understanding of our place in the cosmos, we will know soon enough. Keep watching the stars. They have stories to tell us if we are patient enough to listen.